All right. So what we got here is I had worked one that was similar to this, what we call an expected value problem, and the expected value is just a way to monetize a scenario given certain probabilities and outcomes. So boy, sounds like somebody's strangling some kind of animal outside. I don't know what that is. All right. All right. So anyway, sorry for the distraction. So what we got here is this company. It's got a certain processor that's going to get sold directly to the public, and it's going to be sold for $2,800, and then they'll get a profit of $452 for everyone that they sell. Now, there's going to be these manufacturing flaws, and some of the processors are defective and cannot be repaired. So on these defective processors, the company is going to give the customer a full refund. Now, suppose that for each one of these processors, there's a 12% chance that it is defective, and of course, 88% chance that it's not defective. And the way that I've tried to handle these or tell you how to handle these is do just a little chart and just put the outcomes, and then you can put in the probabilities. All right, so I'm gonna try to do it a step at a time. So there's really two scenarios. Either defective or not defective. All right, so they give us the probabilities. So I'm going to write those in there because I want to be able to think about the other things first. So probability of X, and then this is just going to be X. All right, and we'll talk about what X is in each case in a second. All right, so the probability of it being defective was 0.12. And remember, you got to do it as a decimal. And then this one is going to be the complement. If you got any questions, just Yelp or whatever. Somehow I got into full screen mode here. I don't think that's where I want to go back and look at that problem. Well, hit something. Oh, F11. Okay, there we go. All right, so here's what we got to think about this. If the processor is defective, and I want y'all to help me with this because we got to think about it carefully. If the processor is not defective, then they're going to make about $452, right? But what happens if they have a defective one? How much are they losing there? They're not just losing that that profit. They're losing everything that the customer paid because they got to give them their money back. All right. So that's negative. Right? They essentially just got to give the people the money back. No profit, and they're even losing whatever it was they put into manufacture of it. All right, so now the next one here is going to be what's called X times all right, so I'm just going to multiply each one of those. It'll help me make sure I get it right because these night classes, I end up going to sleep early. All right, makes sense. I'm just multiplying the 2800 negative times the 0.12. So very similar to what's going to happen on the other side. Is 452 times 0.88. So this one's going to be positive. All right, now there's a formula in here, and I think I showed you folks, but remember the formula we're using is essentially we got to add these up. The formula looks like this. I think I showed you this. I dropped it into my little notes last time we were looking at this. But what we're trying to find is expected value E. And what we got to do, well, what we've already done is X times P of X. That was the first one. And then the second one was the positive one, the 0.88 one. And this is just a formula that shows you that it doesn't really matter how many different scenarios that you got. You can have more than just two. So in theory, it can just go on, and you just add them all up. All right. So that's what we're doing. So E is equal to I'm not going to put the dollar sign just for the moment because let's make the math a little bit easier. So we got 397.78 minus. So this is going to be positive because the negative is smaller than the. All right. So just to sum it up, Okay? Does that make sense? All right, so let's go back over and answer the question. If there's anything that doesn't make any sense about that, let me know now before I go over, because this is important, and this is why I have a chart. It's because the chart helps me put things in the proper context of rows and columns. So back over here. All right. So Digitalis, which is the company, can expect to make money from selling these processors. And I can't remember what the darn thing was. That was 60. Go back over here. 6178. So the company can expect to make $61.78 per unit, and that's in the long haul. That's not for any particular one, because remember, they're either going to make 452 or they're going to shell out $2,800. Those are the only two options. But when we take into account the probabilities and all of these things in context, then this just tells us what we could expect to happen overall. It's very, I mean, and this is important for setting things like insurance rates, and there's probably problems like that in your view that may have to do with insurance. And that's really how companies can set these prices, because they know overall, as they do it over and over, they can expect to have this much. All right, so let's say we jumped. I had them written down here. So 13 was the next one we didn't do. All right. Now, you got to watch what the wording of these things are, because sometimes they'll switch things around. You may have this problem maybe one iteration in your Alex, and then for the next iteration of it, they'll swap A and B, because what this says is, given A is 0.57 and B is 0.12, it says A, find the probability of A or B given that A and B are mutually exclusive, and then B says find probability of A or B given that A and B are independent. All right, so two different scenarios. When I did this in my other class, they had them, the first one was independent. Now, I would much rather that they say not mutually exclusive for B, but they choose to do it like this. But this is what it all boils down to. We need that formula. All right, the OR formula. And I'm just going to write that OR formula down in case you don't remember it. I can't type worth anything tonight. All right. So that's the formula for finding the probability of A or B. You simply just add them up, and then if you have something in common, you got to subtract it out. All right, because that's the one formula that's for everything. I'm not big on books that have to write it twice. It's the same one. If they're mutually exclusive, then that's going to be 0. It's not 2 separate formulas. So let's go back over. Well, I tell you what. Let's see if I can. The bad thing is they don't let you copy these. I guess that's just so they don't want you to put it online or something. All right, I'll just write them on here. So 0.57 and 0.12. All right. All right, that's A. Put A in front of it. All right, so it's really pretty easy if it's mutually exclusive. So we're just going to add the 2. That means then that the probability of A and B is 0 because of mutually exclusive. So then it's 0.57 plus 0.12. All right. Okay, so remember, this is something we're just going to need to know is this. If they're independent, times. All right. So that's the AND rule, essentially. So if they're independent, then it's real nice and easy. You just multiply them. If they're dependent, that generally means that something's going to happen to the second one, and you can adjust it. In this kind of situation, you'd have if they told you that well, it wouldn't matter whether they were dependent or not. Uh, in either case, it's not worried about that anyway. It's only talking about the independence. So anytime we want to find A and B, doesn't matter what they are, we just multiply the 2 probabilities, whatever they turn out to be. The independence issue, the dependence issue is handled when you calculate the actual probability of the second one of the B. But we've already got them calculated here. Let's tell you what, I'm just going to write them here. We already wrote the formula up there. So we're just using the thing up there at the top. So that's 0.57. You know what? I kind of messed up already, but I can go back and fix it. times 0.12. So let me do it on a calculator. We already know what the A and B is. We did that, but 0.57. All right, so 0.69 minus, and if you multiply 0.57 times 0.12, you get 0.0684. Oops, it's 6. All right. So just two different ways to handle it. You just got to remember, if they're independent, then you got to do the multiplication of the two and subtract it. Because if they're mutually exclusive, there is no and. All right, because both don't exist if they're independent. I mean, if they're mutually exclusive. All right, let's see what else we got. Number 14 was next. Like I said, if you got a question, just yell. I like questions because it breaks up my makes the time go fast. Oops, it was 14. Okay. All right. This problem deals with what we would call the conditional probability. And how do we know that? Because they have that keyword they're given. So what that means is the denominator is going to be whatever follows the word given, and that is suffers from diabetes. Okay. Well, they tell us that right here. Suppose that 3% of all adults suffer from diabetes. Okay. Hold on a second. Let me do this on here real quick. Make sure I'm not just. And again, this is one of those that it's writing it backwards. So keep that in mind, because when I did this one in my other class, okay, so anyway, the reason why that's important is because A is the one that's asking for the conditional probability. And you can go ahead and calculate that conditional probability with the first. But the easier way to do it is, okay, it says find the probability that the randomly chosen adult who is obese also suffer from diabetes. Well, that's this one right here. So now, remember, let me go back to the board here. So just remember, this is the old formula for probability of conditional. And I'll handwrite it out, and then I'll we'll change it to reflect our situation. So oops, that's not what I want. And then up at the top is both. All right. So let's just say what was it? It was given. Well, I'll just copy and paste this because there's nothing in it. And I don't have to write the words down. I mean the numbers down, but all right. So the probability of diabetes, we'll just put that. I think it was 3, right? And then the probability of obese. All right. And then the probability of both. I'll write that over here. It's 2%. All right. So this is the probability of diabetes is 3%. Probability of obese is 28%. And then the probability of both is 0.02. Now, what I'm going to do is I'm just going to write that out by hand, and I'm going to put it the way that it was given, asked for. Probability of obese given they had. So what does that mean? Well, it means on the top, I'll put the bottom first. So this is what follows the little line there, that little slant that says given. Made it one too short. It's too short. I have to write it. Okay, so that's easy enough to do. We're just going to write the values they gave us because they're right there. Like I said, the first time you see it, they may have the given as the second one, and then another time they'll do it as the first one. So just kind of remember that. Because you really need this one as the denominator. So this was a 0.033%. And then this is the both, right? Yep. And you know you're in the right ballpark because the larger one is in the denominator. And that's going to be 2/3 essentially. And 6, 7. All right. Any questions about that one? All right. So that was number. That was number 14. Let's see what number 15. Oh, okay. All right. So you got to kind of watch these. These can kind of blow your mind a bit, so to speak. All right. As a matter of fact, when I do, I have to kind of go back and refresh my memory. It's a good thing that I had just done this yesterday. But what they're asking is they're giving us two events, and they want to know if they're independent or dependent. All right. So let's kind of look at this and think about this. All right. So first of all, a litter of puppies consists of black puppies and white puppies. A puppy is randomly selected and removed from the litter. Okay, it means you're going to take him out. Then another random selection is made from the remaining puppies. Is this independent or dependent? Well, first of all, even before we look at it, well, they describe the two events as event A and event B. So they're being specific about what the first one has to be. But even if they didn't tell you that, your selection of that second puppy is going to be dependent upon what happens in the first event. Hold on a second. Because they're not put back. They're not put back in there. So, and like I said, is you got to watch these because there was one that I saw yesterday that was very similar to this and almost wording, and it was they put the pieces of paper back. It was like slips of paper. All right, so we got a family of 2 children, and we're talking about eye color. So we got to have the first selection has got to be a boy. In other words, the older child has got to be a boy. And then the second selection, the second child. Oh, wait a second, wait a second, wait a second. I'm sorry. I'm reading the wrong thing. I'm on the wrong one, but I was reading the piece of paper thing. But the first event, event A, is the older child, and they've got to have brown eyes. All right. And then the second child also has to have brown eyes. So both the older and the younger. Now, these things are dependent. That second one is dependent upon the fact that there's no way to have a second child with brown eyes and have the whole family, or you got to have both children brown eyes without the first one. So this is dependent. All right. This cannot happen unless A happens. All right, so this is the one I was thinking of before. They just, like I said, they've had them mixed up. A hat contains slips of paper with the names of boys and girls in class. A name is randomly selected and returned to the hat. Then another selection is made. All right, so the first selection is a boy. First selection is a boy. All right, but you're putting them back in there, and you got a blank slate now. Now you're picking again, and you want to have a girl. So these two things are independent of one another. Box contains some pens. Some pens have ink and some do not. A teacher randomly selects a pen and sets it aside. So it's getting set aside. Then another random selection is made from the remaining pens. Okay. So because they're not being put back in, we've got another dependent situation here. Because the probability of that second event has now changed, because it doesn't tell us how many pens are in there, but let's just say that there were 10 pens. Well, when you're taking that first pen out, let's say it was even money, 5 and 5, 5 with ink, 5 without ink. So one of them is being pulled aside, and it's a pen with ink. Well, now there are only 4 pens with ink in there and 5 without ink. So your probability now has skewed because of that first pick. All right, so here's the last one. At the beginning of each of 2 football games, a coin is tossed, and the winner of the coin toss is determined. All right, now coin tosses generally are independent, but let's just see what the event is. Event A, in the first game, the home team wins the coin toss. All right. So just 2 games back to back, let's say a doubleheader. So it has nothing to do on that second pick to do with what happened on that first pick. In theory, every time you flip that coin, it could come up heads. We know the probability is that it comes up about half heads and half tails over the long haul, but probability wise, we can never predict. So these things are about as independent as you can get. All right, 16. All right, so you're sure you don't have any questions? Oh, and I kind of figured that they would do it, but today would have been the drop date, and it would have been like 1 p.m. or something if you wanted to drop it. They extended, I think they extended it till next Tuesday, maybe. So I don't know that anybody needs to drop. I mean, generally, as long as you're keeping up with the work and you're, making a reasonable showing on the tests, you should be able to pass the course. But if you got any questions about that, ask after I finish this, okay? This is about the smallest class I've had in a long time. I think there's like only 6 or 7 people on the roster that's left. There was never that many. It was more like 10 or 11. All right. So here's more dependence and independence. Now, let me kind of explain a couple of things. This one, there's 2 different properties here at work. All right, first of all, the one that we looked at when we did that multiplication we had to do for mutually exclusive and then independent, we went through that procedure. Well, that's the same thing as one of the principles we're going to be using here. All right. So let's do this one first, and I'll show you why, because it's the easiest one. If two things are independent, then you should be able to multiply those two probabilities, and they'll come out to the probability of A and B if they're independent. In other words, 1 times 1 is 1, and 4 times 3 is 12. So as long as multiplying the two independent probabilities gives you that, and then these are independent. All right. Now, there's another concept, and I'll kind of try to write it out for you. There's two different ways to look at it. Let me write it on the board. All right, so the one is like what I just told you. All right, now here's the other one is, and you can write it two different ways, sort of like how you can do that with the complement rule, but it's not the complement rule. So the probability of B given A, if they're independent, is just equal to the probability of B. All right. And then we can also do the do it the other way. Probability of A given B is equal to the probability of A. So those are two things we can count on. The last two are the first one is just the multiplication rule for independent events. And then the second one is just, it's kind of just a subcategory of that, but you can write it two different ways. That the probability, the first one is the probability of B given A would have to be equal to the probability of B if the two events are independent. Or if the probability of A given B would have to equal the probability of A. All right. So let's go back over here and put those things to work. So we're given here, oops. So we've already done that first one. So then we're going to look at one of the others of the two. So on this one here, the probability of B given A should be equal to the probability of B if these are independent. So this right here, probability of B given A, should be equal to the probability of B, whichever one comes first. Okay? And so those are not equal. So these are dependent. So here's another one. The probability of B given A is equal to 1/4, and it's also equal to this probability of B, so these are independent. Now here's the one where it's flipped around backwards. These two were like the middle one. So the probability of A given B is equal to 1/4. And so the probability of A is also 1/4. So these are independent. So the probability of A given B is equal to the probability of A. So these are independent. All right. See, we did 17. Let's look at 18 and 20 is the ones that we didn't do. All right. And 20 was just a repeat of one we just did. We'll probably just get that real quick. And then, like I said, we'll take a few minutes to go through the beginning of chapter of a little bit of chapter 12. And then after you take your test, I would just recommend getting started on that, the learning path with that. So like I said, the end of the semester is going to come quick, and then you're going to have the chapter 11 test, and then before Thanksgiving, and then after Thanksgiving, the exam on everything. All right, so 6-numbered balls numbered from 1 to 6 are placed in the bag. Some are gray and some are white, as shown below. All right, what is the probability that the number greater than 4 is selected? Well, 1 is not greater than 4, 2 is not greater than 4, 3 is not greater than 4, 4 is also not greater than 4, but 5 and 6 are. And I'm going to write it like that first, to just let you see it in action. 2 out of the 6 are greater than 4, but we always got to reduce them. All right, so what is the probability that a number greater than 4 is selected? And here's our keyword here again, given. So this is what we're going to restrict our denominator to. What follows given? Given that a ball is white. So we can ignore these two over here, 1 and 4. And we're only going to look at the white ones. That's what given is saying. Only look at the white ones. Now, out of those 4 white ones, how many are greater than 4? Well, you know what? This isn't like a trick question. How many are greater than 4? There's still 2 of them. But now there were only 4 to choose from, because we essentially took the 1 and that 4 out of the mix, and there were only 4 in the bag, and 2 of them were greater than 4. All right. And like I said, we did number 19, and that's on the other video. And so let's just do this one again. Like I said, this is the exact same one. I don't know how to get in there twice. All right, so it's essentially just we're going to multiply. Well, for the first one, well, let's do this one first, because that just means it's going to add them up. And you know what? I forgot about this little thing. I don't know why I always forget about it. So B is 0.38 plus 0.32. So that's 0.7. All right, now watch. I'm going to put the whole thing in here. This is what's kind of neat about this calculator. So for the first one, we got to add and then subtract that product. Now, order of operations, it should do that first, but I'd put the parentheses in there to force it to make sure that it does that multiplication first. And then I always like to do things, sometimes if I do something complicated like this, I want to just double check it. Let's see, 0.38 times 0.32. So that's the number we're subtracting. There's no like change sign thing here. I'll write it down. All right. So 0.7 minus 0.1216. Same thing, see? So you can get that calculator to stack things and do things in it. All right, so that's pretty much it for that review. We've gone over, so the first video that we did, well, it would have been last Monday now. That one is up there. I've also put it into YouTube. I'll put this one on YouTube just so that if you want to come back to it later, because I think they only keep the videos on there for a couple of weeks in Canvas. Sure. All right. All right. At a school's open house, t-shirts and sweatshirts were sold. Each item was purchased by either a student or a parent. All right. And then they just give you a summary of that. The rows are the student and the parent. And then the columns are the type of shirt, t-shirt and sweatshirt. Now we're told that all of these add up to 50. And again, I can't select it and show you, but hopefully you can see right there. That's 50. That all of them add up to 50. So whatever we're going to do is going to be over 50 for this first one. So the probability of a t-shirt is we need the total of a t-shirt. So let's see if we can just take advantage of this. So that's t-shirts, right? 12 plus 18. So there were 30 t-shirts. And then we're going to divide that by 50. So it's a neat little calculator. So this is 0.6. So remember that. Well, we're going to write it on here. So now, this is all the same. And this is all this. It's just kind of neat. There's more of this conditional in here than anything else. They just keep coming up in different forms, but they basically all take you in the same procedure. You're doing the regular one, then you're doing the and. So the and means that we're only looking at student and t-shirt, which is 12. All right. Because if we want to find the number of students that also got a t-shirt, or they're a student and a t-shirt, then there's 12 of them over 50. All right. Now, let me go back. And we're going to use this again. All right. We did them. This is the one we just did. We did the t-shirt and student. And then this one was, what was the first one? Was whatever it was, but they did them in order. I don't forgot what it was. But the and goes on the top. And then the other one goes on the bottom. All right. So this one's going on in the numerator. And then the denominator is the 0.6, the t-shirt. See, because it's saying given t-shirt. So when you say that, what follows given is what goes on the bottom. Okay. You all right? I mean, if you got any more questions about anything, go ahead and ask. I mean, I'm not. I think we'll be all right if I don't start going over anything new. I just don't want to assume we're not going to miss any more days, because I had assumed on 2 hurricanes ago that was going to be the last one, and it didn't work out that way. So, and I don't know. It's just when I've had some bad experiences over the years with this. It can make it for a terrible situation if we just got to cover a whole bunch in just a short amount of time. But anyway, I'll just kind of equip you with the basics, and then we're not going to do much as far as calculation. But if you got another question on this, let me know. And like I said, if you got anything about grades and all that, just hit me up in private afterwards. All right, but that's but the average in ALEKS should be pretty accurate. It's supposed to synchronize over to Canvas, and I'm generally accustomed to, in this class, doing some kind of adjustment on the grades before the final exam. The only problem is, since we kind of got our hands tied about using Canvas now, since we're doing all this virtual stuff. During the summer, I did an experiment with using the curving feature in there, and it made somebody's grade worse. At least that's what they told me, and I never could figure out. So I'm a little bit hesitant about saying that I'm going to do that. So I may have to just kind of do it in a spreadsheet, and like I said, and put it, so your grade will probably end up being a little bit better than it is in there. But that's, the worst case scenario. Your grade's not going to get any worse than the grade in Canvas. All right, but let's just talk about this, just kind of briefly, about what chapter 12 is all about. Now, the good news is, usually when students get past